the angle between AH and the plane is the angle between, in the right angle triangle goes from A to H to F. That's this angle here. So let's draw that right angle triangle out separately. And we know this is 8 centimetres, but that's all we know. So we need to know what H to F is. So if we look at the base of this cuboid, H to F is the diagonal of the base with 17 and 5. So Pythagoras will let us work out what x is, because x squared is 17 squared add 5 squared. Opposite of square is to square root. Coming back to our original triangle, we can do Socoterra. There's the angle, go across to the opposite side. Start at the right angle, go across to the hypotenuse, and the spare side is the adjacent. So we now know this H to F is 17 point. So I've got O and A, which is TOA. I'm going to use shift tan of the O divided by the A. So shift tan of the O divided by the A, which is still stored in my answer. And my calculator tells me it's 24.297. To one decimal place, that's one number after the decimal point, it's 24 point, the 2's followed by a 9, so it rounds up to 3. Formula for the area of a trapezium is A plus B over 2 times H, and we know that needs to be 119. So let's put our information in. So A is x plus 6, B is 3x minus 4, over 2 times H, which is x minus 1, must equal 119. Simplify this, so I've got x plus 3x is 4x, positive 6 subtract 4 is positive 2. Opposite of divide by 2 is to multiply by 2. And then I can do FOIL. So first is 4x squared, out as negative 4x, in as positive 2x, last negative 2. Put it all on the left hand side. I've got 4x squared, negative 4 add 2 is negative 2. Bring the 238 over, so I've got negative 2, subtract 238, which is negative 240. And if I halve all the terms, I get the required equation. To find x, I can use the quadratic formula, where A is 2, B is negative 1, and C is negative 120. And the quadratic formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. So So I'm the negative of -1 plus or minus the square root of -1 squared minus 4 lots of 2 lots of -120 all over 2 lots of 2. And I'll get two answers, a positive and a negative. So when I do plus, I get an answer of 8. When I do minus, I get an answer of -7.5, which can't be the answer. So x must equal 8. This is the 6th step, rearranging. So we start by multiplying up by the bottom. Then we expand the bracket. M times t is mt. M times -3 is -3m. I want to move all the t's to the left, so I'm going to subtract a t. And anything without a t to the right, so I'm going to add 3m. Then I factorise out t. And the last step is to divide by the bracket. So I get t equals 1 plus 3m over m subtract 1. ODC is this angle here. That's what I've got to try and find out. Right, what do I know? Well, if this is 75, this angle at the centre will be double that, which is 150. I've got a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral add up to 180. So 180 subtract 75 is 105. This angle and this angle in my isosceles triangle, so if I do 180 subtract 150 divided by 2, each of these is 15. So I've got 105 and 27 and 15 and 150 and my red angle to make up a total for a quadrilateral. So I've got 105, I've got 297, quadrilaterals add up to 360. So it must be 63 degrees that's missing. Right, correct to the nearest, so that's my hint that this is a bounds question. So 4.5 could be as high as 4.75 or as low as 4.25, half of that away. 3 millimetres, oh that's in centimetres, so let's change that to millimetres, 47.5 millimetres, 42.5 millimetres. Spheres, the 3 millimetres to the nearest millimetre could be 3.5 or as small as 2.5. If I want to make a lot of spheres, I need to start off with a lot of metal. So let's have the sides as being 47.5 cubit to get the volume, and then I divide by the volume of a sphere, which is 4/3 pi, and I'm going to choose the smallest radius. and see what I get. I get 1637.46. So I can make 1637. I haven't quite got enough to make the last one.